from across the globe, from the center of aerospace. And now to you.
Thank you for downloading the Aero Society podcast from the Royal Aeronautical Society.
Good evening, everyone. It's great to see so many people. I think we've got over 150 people, so thank you very much for being here this evening. My name is Anna Pedras. I'm the Vice Chair of the Heathrow branch of the Society, and on my day job, I am a university lecturer at Kingston University. I'm particularly interested in themes related with aviation and sustainability. Before I introduce the speaker tonight and the presentation, I just got a few housekeeping points. So, first of all, there is no planned fire alarm test for this evening, so in the event of a fire alarm going off, I'm going to ask you to go through the exit, either that way or that way. It's just right behind the screen, so just go into the garage, don't go into the building. Just follow us, I think. We'll be heading in that way anyway. On another point, I want to remind you that Waterside is a secure building, so please, for those of you who are not coming from within, you cannot wander around unescorted. Also, smoking is not allowed anywhere in the building, and please, if I can ask you to switch off your phones or just put them in silent. And that's it for the housekeeping pieces. Today we're extremely privileged to have a very special guest lecturer. I guess his presence has created great expectations, so you all have the opportunity to ask questions. There will be a Q&A session after the lecture. So if I can ask you to make sure that we all can hear the questions, there will be a rolling mic. So if you can please speak clearly, introduce your names, and if it is appropriate as well, your affiliation. So thank you very much. Just let me introduce our lecturer tonight. It is with great pleasure that I welcome our guest speaker, Sir Brian Burridge, Chief Executive of the Royal Aeronautical Society. For the last 2 years, Brian Burridge has been responsible for the operational command of the Society. So naturally, in this role, he is uniquely placed to share with us not only the challenges of the unstoppable march of the technology and science, but also his views of the Society's mission and purpose in what is being called the Fourth Industrial Revolution. Until his appointment, Brian Burridge worked as Senior Vice President in Leonardo, chairing 2 of the group's businesses and holding board positions in the trade associations, ADS, and the Defense Growth Partnership. Earlier, Sir Brian spent a full career as a pilot in the Royal Air Force, holding a frontline command at every level in the service, including the National Joint Command in the 2003 Iraq War. He also spent a number of years in the UK Ministry of Defence in policy posts, leaving the RAF in 2006 as Commander-in-Chief of a Strike Command. Brian read physics and electronic engineering at Manchester University. He holds an MBA from the Open University and 2 honorary doctorates. It is fair to say that with that fruitful academic career and his connections throughout the aerospace community and his commitment to the development of the next generation of engineering talent, Brian Burridge is excelling at raising the profile of the Society in the industry. We are very grateful for your generosity and for your willingness to share with us what you know, and what you know you don't know. So, let me introduce you a little bit about us, the Heathrow branch. As you've probably gathered by now, if you've been paying attention, we are a very international branch. We are very diverse, and our members come from a very huge range of organizations and companies around Heathrow Airport. Also, their fields of expertise span many fields: engineering, finance, academia, and many other professions. In our daily jobs and in our volunteering activities, we try to fulfill the aims of the Society. Through our program of open lectures, we support the continuing professional development of our members. Through our involvement in primary schools, technical colleges, universities, we try to encourage students, talented young students, to take STEM activities. and also to promote the excitement of aviation. We fulfill as well our objective as a charity in servicing the needs of the broader public through a variety of activities. It is a real pleasure to have you with us, our CEO. We are looking to you for direction, and also we are looking to you for inspiration. So welcome. Enough of me, and now welcome Sir Brian Burridge.
No pressure there then. Okay. I promise you, before, or I was on the point of becoming the CEO, I was actually writing my PhD, so to regularize all my doctorates. Known knowns, known unknowns. You recognize that, of course, from a well-known person whose name I will not remember, but with not mention, but it's Don Rumsfeld, and I worked with him, obviously, in the past. Aerospace is important, aviation is important. There are two factors about both of those that make them important. One is that they are both long-term gains. You don't get a return for quite a long time in making your investment, and the second is they're both huge enterprises. And in particular, if I just dwell on aviation, aviation carried 4.4 billion passengers in 2018. Every second of every day, there are 1 million people in airplanes not attached to the earth. It contributes, and merely the airline and aviation sector contribute $2.7 trillion to the global GDP. That's 3.6%. Over a third of all traded goods by value travel by air. There is a global fleet of 32,000 airplanes currently, and that's set to change. And they cover 62,000 routes. And we know that. That is a known. Where that's going to go is still pretty predictable for now. What we don't know is the impact of shocks. And shocks happen. And by comparison with the present day, SARS in 2003, the impact of that on Asian Pacific Airlines as a cluster was they lost 8% of their passengers and their revenues went down by $6 billion. North American Airlines, not so badly affected, but they lost 3.7% of their passengers and their revenues went down by $1 billion. The impact on the global economy was $32 billion. Those are big numbers. The leverage into the global economy by China is about 4 times the level that it was back in 2003. Also, in terms of airline volumes, there's 17 years of passenger growth, and generally passenger growth in Southeast Asia has been growing at about 3% year on year for the last, up to about 5 years ago. It's now up at 4.5% year on year, and we expect that. If nothing unusual happened, we would expect that to continue. But coronavirus is with us, and we don't know enough about where it's going to end up. What we do know is, based on previous similar pandemics and health issues, that regaining previous volumes of passenger traffic has taken some time. But apart from that, Boris Johnson said today, this is the year of climate change. So I'm going to talk quite a lot about climate change and sustainability. The interesting thing, of course, is we've got COP26 coming up in November, to be held in Glasgow. We are co-hosting actually with Italy, and the COP events have started, and the Young Persons COP event will be held in Rome. So where I want to start is just having a look at the megatrends that affect aviation. And this is some research we've been doing. It's based on, with one of our corporate partners, who's Canada, Montreal based, and they use their subject matter experts to start positing what you should do about these megatrends. I'm going to talk in detail about climate change. Demographics, of course, is affecting passenger flows. It's also positioning the way in which people use their leisure time. And generality is that in Far Eastern nations, there is, say in China, an aging population. You move to the Middle East and India, there's a decreasing median age. And over in the Western Hemisphere, there is a prosperous, aged silver surfer, of which I am one, and proud to be so. The way in which people choose to invest and use their leisure time is significant in terms of age demographics. The global economic power shift is probably one of the most important things that affects the global economy, and it affects many agreements that come out of the rules-based international order. Because what we have seen over the last decade or so are two things. The G7 nations and the E7 nations, which is the Southeast Asian economies plus Mexico and Turkey, so 5 in the Southeast and those 2 others. It's the BRICS plus 2, it probably is the best way to express it. Those sets of economies in the period 2016 to 2019 are just about in balance. But now the E7 total GDP is greater than that of the G7. What will happen as China's economy either goes down and doesn't come up or whatever is unpredictable? But on current predictions, by 2040, the E7 will be double the value of the G7. Similarly, intellectual property is transferring to the Eastern Hemisphere. If you look at the league table of the top 20 technology and engineering universities for research, teaching, postgraduate teaching as well, if we were having this conversation 15 years ago, there would have been 15 US universities and 5 in Europe, of which 4 would have been in the UK, Oxford, Cambridge, Imperial, and UCL. Now, there are 9 in the Eastern Hemisphere, 2 in Singapore, and actually only 7 in the US. There's some big changes going on in the US in the way in which young people want to develop and make money, all about startups and that sort of thing. But this is astounding, because these are top-rate research universities generating intellectual property, and we can tell that from our journal, because the papers that are being submitted, we have a much bigger segment now from Southeast Asia, including China, and we got our first paper from North Korea, and that's causing us a few diplomatic problems because it's on hypersonics, would you believe? So this shift is significant because in supranational fora, then your ability to influence opinion goes according to what looks like your political capital, your convening power. So if you're in a big economy, and if you are in an economy which is productive, which is at the leading edge of science, then you have more of a voice. This is important when you consider, and we will do, what's happened in Corsia, the United Nations through ICAO emissions control system. Of course, the big one too is innovative technology change, and we're going to talk about the 4th Industrial Revolution and the technologies affecting future flight. Rapid urbanization is obvious when you look at the megacities in China, and they're there. They're not something that's going to happen, they're there, and they're getting more of them, and it's not unusual to find cities in China of greater than 10 million, and we know a lot more about them now because many are subject to quarantine. And global connectedness, the intimate and continuous connection across the world. When we were doing this research, I interviewed a large number of aviation and aerospace leaders in Europe. And They all ultimately had a similar mental model like that, except for one difference. All of them were concerned about the breakdown of the rules-based international order. Things like the tension in the Middle East, things like trade wars between China and the US, and things like the sort of discomfort of events like the Salisbury poisoning. So it's worth just having a look at the way the defence side of things looks at these, and this is from the Defence Doctrine and Concepts Centre, or Defence Concepts and Doctrine Centre. And they have the same list, they have the same big list, but there's some others as well that they have, which are nevertheless quite interesting. And they have in their list this sense of a change in the rules-based international order. They diplomatically call it adaptation. They also recognize a serious issue about increased competition for the global commons. This is the oceans, space, cyberspace, the polar regions, etc. This is a dystopian list, if you ask me. I mean, it kind of makes you feel uncomfortable just to see that they're the sort of risks that worry those who look at international security and defence. It's certainly the case that we now have the concept of fighting in the grey space, this below threshold cyber attacks, fake news, poisonings in Salisbury, these sorts of things which are unattributable, potentially, difficult to prove, and very difficult to deal with if you're a Western liberal democratic nation. So we need to take note that, you know, the world is changing, and we cannot predict what the implications of those changes are going to be. So with that as background, this is the way we look at it in the society. These are the big issues. First and foremost, climate change. That's the bird of prey. You may know the Airbus concept model, and if you look very carefully, you'll find our brand on the side. It was an initiative we supported. But climate change is fundamental to both aerospace and aviation. Hence, we're going to dig into that. And I'd like to think that branches will find this interesting, intriguing, and will want to dig into it as well. The second is future flight. This is the government's term in the industrial strategy for those technologies in the fourth industrial revolution which are particularly related to aviation and aerospace. And I am on record, and I will say yet again, that I believe that aviation and aerospace will be the most affected sectors by these technologies. Specifically, AI, artificial intelligence, autonomy, electrification, and digital connectivity, because they revolutionize how we design, make, fly, operate, and use airplanes. Fascinating though that is. And it's all very well, but unless we have the depth and extent of the skills adapted to be able to work in this era, then we're in trouble. And it's not only about apprenticeships and graduate training programs, it's about primary school kids. It's also about people who maybe did their degree in electronics 20 years ago, who find themselves absolutely out of date with the stuff they learned. And I always make people laugh, and I'll have a go at you. Tools of my trade when I was an undergraduate was a slide rule and log tables. And I say that to apprentices, and they have no idea what I'm talking about. And, you know, that's what transformation actually is. So let's kick off with climate change. And this is probably the largest part of what I have to say, and it is the most important. We'll start here because someone once challenged me in this branch. But this is it's properly validated. It's a Bayes-Defra piece of work about what are the emissions, and in this case we're talking about greenhouse gas emissions, so that's carbon plus, from different sorts of transport. And I haven't got HS2 on there, but they have a great narrative about HS2, which you may have read about yesterday and yet to be proven. But the obvious things, domestic flights, because you're not on the cruise very long, heavy on fuel, and the non-CO2 emissions, which is NOx, contrails, and soot, are significant. And in a way, and we'll come to this, but it's interesting, we have, in terms of the legislation on climate change, we are absolutely focused on carbon, because that's the bit we understand. And there is very little focus on the non-CO2 areas, well, I'll show you a graph in a minute. So long haul, necessarily more efficient, and one person in a car is the worst thing in the world for carbon. I drive an electric car, I'll have you know, frequently on my own. But just imagine you're here, you're looking at the systems of systems that an airport actually is, and you're having to work out the interrelation of that. And that's a really complex problem. So our greenhouse gas emissions from aviation stand, depending on who you ask, either at 5.9% of the global total, national total, or 6.2, I've read only this morning. But it isn't just about carbon, and I know that because the Daily Mail told us. This is interesting because it's an erudite report led by Imperial College. We have a specialist group, Greener by Design. We're probably the leading edge thinkers on contrails. We've been pressing the CAA and NATS to run a contrail trial in the oceanic airspace to no avail. We've been doing that for 5 years. But the report's now come out. The EASA are also producing a parallel report, and people are starting in climate science, are starting to latch on to contrails. And I've always been a bit bemused by this as a military pilot, because you get your MET brief and it tells you where the contrail layers are, and that's where you avoid, because if you don't, someone's going to shoot you down. So you have to get into the habit of operating in that way. So it's not difficult to avoid contrails, it just needs organisation. But if the Daily Mail says it, it must be true. This is interesting, and this is important because there's a snapshot of where we are now. In 2017, this graph, was 2019, but the data finishes in 2017. So the important thing to note is the gradient of the reductions in other aspects of the economy. So power generation is the big one. We've been more successful, I think, than many people understand of using renewables here in the UK for power generation. The switch from coal to gas made a big difference. And I have a similar graph, I speak in Germany a fair bit, and I have a similar graph of the German economy, and there they still use coal. They still use coal-fired power stations, and they have a big challenge, and they're finding it very difficult to get into renewables. The other aspect that's significant is construction. The building industry has made huge advances in their carbon footprints. So down the bottom here, we've got a few things which are a bit difficult to understand. Agriculture, land, it's land use, land change, and forestry. Agriculture comes in for a hard time, you'll see in a moment. The F gases are fluorochloroethanes, which are man-made for refrigeration, and they stay in the environment. The problem with carbon is, I don't know when this building was built, but when it was enclosed, there are carbon atoms in here, in this room, that were there at the time. Carbon lingers. In London, there are carbon atoms which you can date back to the end of the 19th century. The point about aviation, you'll see, it's lumped in with shipping. And in general, when you see shipping and aviation lumped together, it's about 60-40, 60% shipping and 40% aviation. But we're flat, we're pretty flat. But there's been an increase in passenger traffic threefold since the front end of that graph. The problem is, all those other bits of the economy, if we extrapolate out to 2040 and dare I say even 2050, they'll be close to the origin, and our challenge is that we won't be or anything like. And there are a lot of opinions about this, a lot of research about it, and there are a lot of variations in the conclusions drawn from the research, and that's what I'm going to go through now. The first is from an organisation called UK FRAeS, and they have just produced a report called Absolute Zero. UK FRAeS is a group of 20 academics, senior academics, led by Professor Allwood, who is the Professor of Environmental Engineering at Cambridge, and 19 other luminaries. And this is what they say. The first thing is they say that the baseline on which the legislation of the Climate Act was formulated is absolutely a cop-out, because first thing is it's formulated on the basis of the numbers in 1997. So 1997 is year zero, as it were. They also posit that offsetting is a completely dubious approach, hence the term absolute zero. So not net zero, but absolute zero. Because they say there's no such thing as a Hoover in the sky that will capture carbon. They also say that afforestation is a dubious approach, and posit that we would have to double the amount of afforestation in the UK before we made a significant impact. And they say that new technology won't solve the problem, and the only way is up, i.e. by electricity, but we will have to get used to a world, or at least a nation, in which we use 60% less electricity than we do now. And left over, and they say, quite rightly, this is a climate emergency, which it is, therefore you need this sort of whole of government approach, properly programmed to come up with a result. And I like the Olympic analysis, that's theirs, because the Olympic end date had to be timed to 0.01 of a second, because that's what the global TV companies demanded for the opening ceremony. So when you're doing a major construction program and you've got that sort of end state, that's pretty testing. But the problem areas left, taking their view of decarbonisation, are cement. There is no known methodology of producing cement for construction that doesn't use shed loads of energy. Secondly, shipping. Thirdly, aviation. And fourthly, ruminants. These are poor, innocent cows and sheep. Aviation is on the naughty step. And they say there is no option for zero emission aviation. Therefore, it needs to contract rapidly and it needs to start now. So all airports, except the three big regional hubs geographically, Belfast, Glasgow and Heathrow. Other than those, all other airports will have to close in the next decade. And then in the subsequent decade, all the other three will have to close. And I was intrigued because I met Professor Allwood at the Royal Academy of Engineering. We had a gathering, not as large as this, but we had a gathering of people like me and him and his team. And I went up to him afterwards and I said, I'm really interested in your take on aviation. Do you think Corsair is going to make any difference? And he had no idea what I was talking about. So it just makes you worry. Anyway, the key point there is that we can do this, they say, and many of our most valued activities can continue and expand. Well, it conjured in my mind a sort of, I don't know, rather basic, unconnected type of environment, type of community, type of population, in that, you know, it struck me as we're almost back in the 30s or something like that. And, you know, frankly, it misses out the nature of the economy and the nature of the economic driver that comes out of, you know, all of that stuff, never mind just aviation. So we shall carry on having a discourse with Professor Allwood and his team and challenge them as we see fit. And I'll come to the menu for that in a moment. But they are at pains to point out that their research and the data they use is peer-reviewed, it's pucker data, and there's more footnotes than there are research, but you know, they're serious. And the problem is, this is government, this is government funded, so we worry about these things. We worry less about the Committee on Climate Change because that is a more diverse group, and they are the main government advisors, and it was Theresa May's reaction to their work towards their May 19 report that moved us in the Climate Change Act from 80% of the 1990 level, I said 97 before, sorry, 1990 level, to 100%, so net zero. But they are slightly more sensible. They, again, you know, the huge but more diverse group who contribute to this, they, first of all, believe it's necessary, and I don't think any of us disagree with that, because there is, stand fast President Trump, but there is overwhelming evidence of the impact of greenhouse gases in driving climate change. Now, I'm willing to argue that with anybody, even President Trump. And we signed up as a nation to the 2015 Paris Accords, which require collectively for us to work on the basis that the maximum rise we can countenance in the climate is 2 degrees Celsius based on the beginning or at the pre-industrial age. So the difference in that period cannot be more than 2 degrees, and preferably 1.5, because the band between 1.5 and 2% means you're into irreversible territory. 1.5, it's generally reckoned, it's containable. It's feasible because they say there are the technologies that will allow this to happen, and they provide a fantastic technical baseline for their reports. And it goes into detail about the state of the art on synthetic fuels and all those sorts of things. And they believe that it will just take strong leadership from government just here. They say it's cost effective because the cost of the necessary technologies. The Act was originally enshrined in statute in 2008. So they took a cost, what is the cost of getting to 80% in 2008? And they posit that now in 2000, well, that's May 2019. 2019, getting to 2050 at net zero will impose no more cost. I think that's questionable. UK leadership is interesting, and you know, I've had this personally, and I've seen it on the diplomatic stage. There is no doubt that it is right that the UK should take a leadership issue on this, because first of all, we have some great climate science, we have a great aerospace sector, we have some great airlines, and if there's one place that might just actually be able to get this done, as the saying goes, it's us. It's also good for people, good for the population. But most of all, there's a kind of reputational thing, because most of the world, particularly the developing world, will say, well, they tend initially to say, you Western nations screwed up the climate in particularly the first and second industrial revolutions, and now you're saying to us we can't develop our economies in the way you did. They actually point to us because we were the people who had the first industrialized economy. And the president of Bangladesh, just before Christmas, was talking about the problem of flooding in Bangladesh caused by climate change, and he said, not only are you lot to blame, but you ought to pay. So the notion of reparations comes from in some people's minds. So, you know, I think most people are comfortable that we should take a leadership position. On aviation, though, their numbers are different from others I've seen, but they say that aviation's emissions, and we're just talking about carbon at the moment, can be reduced from 36.5 megatons where it is now, rather, 2017, down to 30 tons. And they see 30 megatons as being the irreducible minimum. You've no idea, have you, what 30 megatons of carbon looks like? Okay, the output of the European iron and steel industry is 96.5 megatons a year. And you can sort of picture in your mind what lots of steel mills looks like. They still are of the view that major technological breakthrough in commercial aviation is unlikely in the time scale. And we're going to go into that in a bit of depth because it gives me a chance to have some pictures of aeroplanes up there. They do believe that fuel efficiency will continue. They posit 1.4% year on year, which is pretty much the way it's been since we got into high bypass engines. And they recognize, there's a lump of engine airframe combinations that will improve things, as well as lighter materials and all those obvious things. And they also recognize that sustainable fuels have got to be something of the answer, and they posit that there'll be 10% take up on sustainable fuels. I have to tell you, it's going to have to be a lot more than that, and we'll touch on that when we come to sustainable aviation. But taken together, this, if you like, is trying to balance what they regard as a plausible and almost inescapable growth in passenger numbers with the decarbonisation. And they say that it is plausible only to allow 25% growth in passenger numbers by 2050. They also point out that in that case, then all those factors for suppressing demand, which are just a different bunch of levers in many ways, and the one that catches the eye is airport expansion. And they make the point that the expansion that's planned in the London area, with no clues for guessing where, actually represents the limit by 2050. In other words, it gives you 25% increase in passengers. So effectively they're saying, so you are where you are. And the degree to which you suppress demand through those other elements of taxation is also interesting. And that's the point, really, that it becomes an interesting political issue. So we'll touch on that. They also, unlike Absolute Zero, recognize the science of carbon capture and storage and recognize it's a vital contributor. And they are right. And these are rational people. They are amenable to argument, and they have done, well, I mean, they've been in being for more than a decade. So, if you like, that's the kind of middle of the road, but that's what government listened to. And last week, Sustainable Aviation released its 2 roadmaps, one on the pathway to net zero carbon and the other on sustainable aviation fuels. And this very effectively looks at the carbon budget. It looks at the climate budget, not activity levels. Because the reaction you get from the sceptical British public, the even more sceptical officials in government, and the deeply sceptical ministers, is they would say that, wouldn't they? But actually, this is quite a sensible approach, and just sort of slips in underneath that, well, if you did this, that would allow potential passenger growth of up to 75%. Department of Transport currently predicts 49% passenger growth. I think I put that on the previous slide. So what do you think the press latched onto? In the press coverage, they latched onto 75%, although that wasn't the main thing. And I think, those of us who are trying to have a sensible debate about this need to be clear that this is actually about the climate budget, and activity levels follow that. But there's still some interesting aspects of how you suppress demand, carbon pricing, and I was interested to see, I know just happens to be the case where I live, a lot of people work in the city, some of them are based in carbon trading, and they say it's the most dreadfully difficult and almost random part of their business. But positing a potential price of £220 per tonne of carbon is quite significant. And that's what the 2050 figure is. Better air traffic management and operating procedures. We've written 2 learned papers published in our journal on the problem that exists globally on matching and optimizing the airplane you use and the sector length involved. So in an ideal world, you'd have a much larger range of aircraft to choose from so that it is absolutely optimized for the route it is on. That is impossible to do until we can find a way of varying the characteristics of individual aircraft at the press of a button. The interesting aspect, though, because it also does sustainable aviation fuels, is a recognition that sustainable aviation fuels on their own are not the answer. It's a bridge until we get to electrification. We'll have a look at electrification, but you ain't going to see a long-haul aeroplane totally electric until well the other side of 2050. But the 3 fuels that we're all interested in, biofuels, which come from things like soya, willow, waste, the electrochemical fuels, favourite there is the mixture of hydrogen and CO2. And there's quite a lot of interest in being able to capture CO2. That's a good thing. Mix it with hydrogen and then produce electricity, and Gatwick are doing that in order to make Gatwick the first carbon neutral airport. The future of hydrogen, though, if I had to bet 80 years' time, future of hydrogen, by the end of this century, hydrogen will be the fuel. Anyway, we'll have a look at that because sustainable fuels, if it's a bridge, are going to be really important. And nobody covers this up. They are expensive by comparison at the moment. And biofuels, for example, can be anything from double to 8 times the cost of a litre of AVTR. And some numbers here are helpful. There's about 1,000 airlines in the world, And the fuel bill for those 1,000 airlines is £138 billion a year, or it was last year. And that's now 40 to 50% of an airline's operating cost. It's only people who cost more than the fuel. And a major airline uses about 4 billion gallons of fuel a year. These are very big numbers. And the issue is, how can we scale up the ability to make synthetic fuels of the e-fuel bracket at a cost which is sensible? And that box there is taken from a piece of research led by Imperial College with their business school. And first of all, you identify the total amount of capacity you need to generate. And so that's where, the comparison with where we are today in billions of gallons is concerned. And you look at the difference, if you like, or 5 times leverage. If you take the carbon out of the air and store it, it costs you £20 a tonne. If you want to turn it into something you can synthesize in order to make synthetic aviation fuel, then it's £100 a tonne. So when you think of oil refineries, and you think of the sort of plants that you need, as in industrial plant, the belief is that you will need capital of somewhere between 280 and 560 billion euro. Now that's in Europe. That's a very large number. It's questionable whether there is that sort of investment will. And bearing in mind that this potentially is seen as a stopgap, because by the end of the century, we will probably be all electric. But these are the sorts of things, and the Royal Society is doing a lot of work on sustainable fuels, carbon capture, etc. So these are the sorts of things that will determine whether we're successful in decarbonising aviation, except for aeroplanes. So up there, released at Singapore this week, and I had a team in Singapore wearing masks, our Aerospace editor-in-chief and one other. So a wide blended body. That's an Airbus model, which they've flown, and their next job is to produce a 1/6 scale and fly that. Those of you who read our blog may have seen our Singapore reports, and there's a picture, an artist's impression, computer-generated graphic of the inside, and of course, it's a fantastic space. It's like this, The one below is Boeing's conceptual aircraft of the future, and of course, we're back to high aspect ratio wings. So very long wings. Those will have to fold because they are that long. They have to be braced because we haven't yet determined the type of main spar that could possibly support that span. And the aeroelasticity of all of that is an interesting problem. But my colleague, President Jonathan Cooper, who is the George White Professor of Aeroelasticity at Bristol, tells me it'll be okay. Good. Up there at the top is the Ultrafan, Rolls-Royce Ultrafan engine with ceramic blades. Fantastic advance, absolutely amazing. And that is such a high bypass ratio that its fuel efficiency is just amazing. Don't have an airline customer, and they're not looking for one until they've gone through further development, because, how can I put this, they learned a lot from the Trent. Down below that, there's 3 electric propulsors. That's what they'll look like. And there are plenty of people producing those things. I mean, there will be ducted fan. Don't think it'll be like electric cars, because ducted fans can be quite noisy. So you get quite a high-pitched whine out of them. Top right from you, that's the 146 at Cranfield. That's the joint Rolls-Royce Airbus demonstrator, which has on the inboard starboard side an electric propulsor, like one of those. Hasn't flown yet, it'll fly this year. It's really interesting, and it starts to expose the practical engineering problems involved because there's 3,000 volts whizzing around that airplane. And it works on the basis of having some batteries as a sump, a turbine generator inside the airplane, and that feeds the electric propulsor. 3,000 volts. We don't know a lot about insulation in rarefied atmospheres. We don't know a lot about contactors, and there's a whole lot of sort of basic electrical engineering to solve there. And then down below that, that's what an all-electric aircraft might look like. Just to place that, and to do a long haul, that we're talking the end of the next, the end of this century. So where are we? Well, EasyJet at Farnborough 2016 said you will be able to go to Paris with 30 of your best friends, actually I think he said 50, in 2030 on an all-electric airplane, not a hybrid, an all-electric. Okay, and they've taken an equity share in Wright Electric, one of the technology leaders in the US. So that's a possibility. We've got the Britten-Norman Islander, again at Cranfield, doing a government-supported program for short-range, all-electric airplanes, which would be ideal for the Highlands and Islands, for example. But it ain't riding to the total rescue. Hybrid will, because, again, if you have really lean burn engines optimized for the cruise, or at least with a wide enough specific fuel consumption that they perform well across a range of circumstances, and you use a couple of electric propulsors and your engines for takeoff and landing, then you can see once you're in the cruise, you can really lean off, and that probably is the way in which hybrid aircraft will look. So we call it greener by design because our specialist group who does this is called Greener by Design, and we can't seem to get away from that title. Interestingly, here's Boeing's view of the requirement for aircraft in the future. 44,040 aircraft, very precise. Note that, and Airbus have a similar thing, and they give this at their investor conferences. Airbus have a similar one. I think it comes out as something like 40,038 or something. But look at the Southeast Asia figures, the Asia Pacific. 17,390, and that, in a sense, that dominates the slug, a big slug of 40-odd thousand. And remember, we've got 32,000 in service at the moment. The cycle of airplane manufacture is 20 years. So we've got 1.5 cycles to go between now and 2050 rather. So you can see the problem in that if you want to design and develop an airplane and get it into service, then that's fine. You could probably do that. Given the will, given the finance, you could do that. But you wouldn't find a customer who's in a position to change all their fleets by 2050. And that is part of the problem. So just dwelling on that for a moment, what are the differences? Where are the areas of conjecture that need to be resolved? Where are the aspects where the science is either being ignored or is not as well developed? Well, the first, I guess, is, I guess we have to all agree that an absolute carbon-free economy in 2050 is implausible. So it is about net carbon. The second thing is that we need to understand is, so what will be the efficacy of carbon capture and storage and how much will it cost? because the absolute zero bunch claim there is no such thing as a carbon hoover. And therefore, it's implausible to even discuss the notion of a net zero 2050. The next thing is the effectiveness of afforestation, because there's some research coming out that says actually we may just have overestimated the degree to which trees suck in carbon. And in any event, I think on current numbers, they're not far off in absolute zero to say you need to double the number of trees. We have trouble with trees because Boris said we're going to plant 30 million trees in 5 years, and we're apparently about, performing at 50% of that level. We need to understand these alternatives, and here at Heathrow, the investment of 100k into peatland restoration is very interesting because that may, it's a biocapture methodology. We're beginning to understand the climate science of absorbing, the bioscience of soil absorbing CO2, and peat is very good at it. What is the commercial viability and the practical viability of scaling up synthetic aviation fuels? Where will technology lead us? Where's electrification going to be? And what will be the attitude of the traveling public? And that is key, because right now, 15% of the population of the UK do 70% of the flying. So we have not seen any change pre-coronavirus on the degree to which people fly. Flight shaming has not migrated out of Scandinavia to the UK. And if it's related to people's perceptions, then where will the politics take us? Because being re-elected is pretty fundamentally your first priority when you're in government. So these are the hard questions. Why? When? How much? Is it safe? And those 4 hard questions are ones that we immediately brought in as the 4th Industrial Revolution started to bite. So that's what we'll look at now, the future of flight. That's the name, as I said, that we find the government have decided to use for the relevant technologies in the 4th Industrial Revolution. Those ones in yellow are the ones that really matter to us. The others will matter, but to a lesser extent. The different thing about the 4th Industrial Revolution from the 3rd, for example, miniaturization of electronics, is that it's accessible across the globe because, as we've said, we've now got research universities in the Eastern Hemisphere every bit as good as those in the West, so they're able to capitalize on it. The second thing is there's a lot of market pull for these technologies. So, everybody is connected, everybody has a phone, everybody wants the Internet of Things and all of that. So there is this market pull. And also, it's amenable to open systems architecture and an app-based kind of approach to things, which means you can react very quickly to demand. You can react very quickly to changes in technology. Makes you responsive and agile. A few problems along the way. We're working hard in the Royal Academy of Engineering to understand how we should react to the application of artificial intelligence in complex systems and systems of systems. We recognize that we have a sort of tension between 3 points of a triangle. In one area, we have the ethics of engineers, as individuals and collectively. To what extent will we be able and competent to understand the second, third, fourth order implications of using AI in a system? The next one is public acceptability. The public going to drive this, or are they going to be reticent, or what? And the third is the role of the regulator. And our debate is, well, who needs to be in a leadership position of that? And we have all decided it's the regulator. And for good reason. My experience in introducing uninhabited air vehicles in the UK in the late 80s and 90s was that the regulator was nowhere to be seen and just gave you the air navigation order to get on with, which is all about see and avoid. But bless them, the CAA have really gripped this, and they're using some funding out of the Pioneer Fund. They've created a sand table, so small companies with wacky technology can demonstrate them to regulators who will give advice about, yeah, I think the route to certification is this, because certification is absolutely fundamental to all of this. And we take a lot of learning from the automotive industry. And there's a couple of things that are interesting, and there's certainly one that concerns us. The one that concerns us is that there is growing up in the aviation applications amongst small companies and startups a notion that, yeah, we understand that the safety case for an aeroplane is based on 10 to the minus 9, and that's terribly rigorous, etc. But these don't have pilots in. These are autonomous. These are working on artificial intelligence. If there are no pilots, there are no pilot errors. So we can lower the safety high jump. Well, I don't think so. Not in public transport airplanes, anyway. The other aspect of automotive is quite interesting. On pretty much a middle-of-the-road electric reasonable limo like a Jaguar Aerospace or something, there's about currently 100 million lines of code, of which only about 1% is safety critical. But that is seen to increase to somewhere between 300 and 3,000 lines of code as vehicles of that nature become progressively more autonomous. And in that situation, you will find, because they're autonomous, that maybe up to 50% of your software is safety critical. More to the point, in an era of artificial intelligence, a lot of that software will be what we call non-deterministic. In other words, it's writing itself as it goes along. So auditing it for safety is a very complex business, but it is a problem that we have to address. We're going to accredit this and certify airplanes and systems, then we have to understand that. As I said, we take a lot of note from the automotive industry, and currently, if there are obviously certification standards for cars and vans and things, and if you took the current requirement for a normal motor vehicle, not autonomous, and moved it into the autonomous space and accepted the same framework for validation, you would have to drive 11 billion miles in order to demonstrate a functionality with a failure rate of 1.09. In other words, that's 20% better than a driven vehicle. And that is impossible. You just can't do that, and that's why we move into virtual prototyping. More of that in a minute. This is the interesting thing now that's worrying. Urban air mobility, I'm sure you've all read about this. Maybe four-seaters, electrically powered, vertical takeoff and landing, autonomous, and running on an Uber-type app for both call-down and air traffic management. Are you scared? I am. But in Dallas-Fort Worth, in LA, and in Melbourne, Australia, Uber are running a trial this year of the first of these vehicles. Not totally autonomous, you'll be glad to know. But they aim to have a service in being in those cities by 2023. This is serious stuff. A lot of investment going in. A lot of Silicon Valley thinking, fail fast, fail cheap. That is the total antithesis of aviation and aerospace. That is not the way we do business. So thank goodness there are companies like Airbus, like Boeing, engaged in this, doing it rigorously, and perhaps setting the standard that is required. But this business of comparing one of these with a relatively advanced normal light helicopter and saying, well, you've got a pilot in the helicopter, so that's why you certify at 10 to the -9, and saying that that's inherently safer, is something I haven't got my mind around yet. And there again are those hard questions, and that's what we're being asked by regulators, by parliamentarians, by ministers, by select committees, by government officials, the media, and the informed general public. So that's our duty as a learned society, to master all this. Interestingly, FAA are just in the certification of 6 prototypes, which will be done this year, and EASA will publish the regulations in February, in fact, for special conditions for eVTOL prototype testing. I think type certification is quite a long way off, but you know, it's here. We listen very carefully to NASA. They enjoy coming to talk in the society because they like the royal bit, and they've produced this terrific framework which just shows people who have not thought it through what you need to think through, and that is a very, very effective analysis of where we're going. NASA are doing a grand challenge this year, and they are leading on a competition which will do a demonstration of as many people who want to come and participate again in 2023. One of the things of interest, those of my colleagues who go across to the US and interact with the urban air mobility community are staggered at the alignment the US has achieved between universities, research labs, government, industry, government agencies as well. And they're all marching in step, and they all recognize the significance of all of this. But we are doing our little bit, and here in the UK, we worry about the society's relevance and profile. This is the list of challenges that were put out last week. There was a workshop in the Department of Business in order to launch this, and companies large and small were encouraged to participate, understand the questions, and get involved. There's 125 million of government grants involved in those 6 questions, and 174 million of industry funding. So this is serious. These are all the obvious things that you would expect in an era where we potentially have shed loads of autonomy and shed loads of artificial intelligence, including air traffic management, which in an era which is further on, like the quantum era, we will be able to, because of the accuracy of quantum timing, we'll be able to put an aeroplane on any point over the Earth's surface, optimized for terrain and weather to 1 second accuracy. So think what that will do to en route navigation. Certainly improve mine. Lastly then, what about these people who are going to get involved and do this? The big change is worth just going back in history to recognize. We went, in aviation, aerospace, we went from Mach 1 to Mach 6.72 in 20 years. I went to university on the day that we went to Mach 6.72. And that gave us, that represented a just bow wave. This is Harold Wilson and the white heat of technology, for those who remember it. And it gave us a bow wave of endeavor. And these impulses of faster, further, higher, get to the moon, win the Cold War, all of that, man on the moon, and Concorde. That came out of that era. Aerospace was exciting, glamorous, and everybody in my era wanted to be part of it. That's what we wanted to do when we graduated. And there was no discussion. It's just what you wanted to do. Because we'd lived through these advances coming up. Amazing things, being able to go somewhere in a jet airplane, for example. But all these things had societal benefit. And that was the culture that was around at the time. How was that possible? shed loads of money, loads of national ambition, and a fair bit of competition across the Atlantic between the Brits and the Americans. So if we can do that in 20 years, is it just possible we can crack this carbon zero in 20 years, 30 years? We've got 1.5 times that. Well, we probably could if we had the national ambition and shed loads of money. But hold that thought. The reason things are going to change is because this is how you make an aeroplane. You use loads of your shareholders' money over 15 years while you design and develop it. And then you put it into service, produce lots of them, make lots of money on the sales, and if you're very clever, you make lots of money on the sales down here as well. But you also reap the benefits of the aftermarket. And that's pretty much a 747 picture. 747 is probably the most effective example of that. There are 1,000 airplanes in steady state in service over a very long period. A couple of problems with that. Certainly in military aerospace, customers will not accept either the research and development costs being that deep or the length of development time being that long. And the challenge in the UK, and we do a lot of work with Team Tempest, a lot of the challenges make it half as long and half as expensive. But the point about skills here is all that stuff above the line will be done by robotics. We're already there pretty much. We can, in the advanced manufacturing catapult, we can do most of the aeroplane production through robotics. So there aren't going to be many engineers working up on that part of the line. They're going to be digital scientists, and we're encouraging the universities that we accredit to teach more digital science in their aerospace engineering courses, but it's a different skill set. Where we need the engineers is where that red arrow is pointing, because we will be living in a world where we do not build physical prototypes. So we'll be building a digital twin and doing virtual design development, testing, and integration and testing, even towards the ultimate of certification. And that is what we're good at, actually, in this country. So if we really knuckle down to it, and it's known to us as the Brunel Challenge, because, again, there's a government program supporting it. If we really knuckle down to it, we can be really good at that. We will be world class. Interestingly, there is... I did some work in Germany 2 years ago on the growth of the application of AI and autonomy to manufacturing. And the German government had created, using government money, a virtual OEM, original equipment manufacturer. In other words, replicating all the things you do in an aircraft factory virtually. And so you ask, why are they so far ahead of us in these things? But also, interestingly out of this, between 1960 and 1980, if you doubled the development cost, you got 50% better fuel burn per seat. If you look at it from 1960 to 2000, 8 times the development cost gave you only a further 18% improvement. So it's an interesting issue around how you invest to increase the efficiency of your aircraft. So, change, we can be good at this, but we've really got to respond to it. We've got to change the way in which we teach aerospace engineering. Otherwise, we won't get to the moon. This is Artemis. Artemis, as you well know, was Apollo's twin sister. Carefully chosen name because 12 men have walked on the moon, and this will be the program that sends the first woman to the moon. That is a key requirement. And it's going to the South Pole. Why the South Pole? Because finally we recognize there is water on the moon at the South Pole. And we had a fascinating lecture from the Chief Technology Officer of NASA, who explained how they've used 50 years of data, in other words, the data from the Apollo series over 50 years, using better and better computation in order to understand so much more about the moon. How it was formed, 4.5 billion years old. For years and years and years, we assumed it was a couple of billion, that's all. Actually, how it was formed, how it spun out of the Earth's crust. Also, that there are rare metals there. There are extensive amounts of platinum, which was $28 an ounce last time I looked. Similarly with other rare earths like palladium and osmium, right the way through to iridium, which is $54,000 an ounce. So if young people, and we always have always struggled with primary kids, because the two ends of science that they really get interested in are dinosaurs and space. And we have a program called Cool Aeronautics with our friend Amy the Aviator, or Aviator Amy, cartoon character, and we take this into schools and we teach them about the history of aviation, and we teach them about the future of aviation, and we get them making aeroplanes and all that sort of thing. And space still captures the imagination. Will this generation get back to the excitement that I had when I was studying? We'll see. And to finish with, I have a question. Put your hands up if you've got the 1974 Pink Floyd album, Dark Side of the Moon. Well, I'm sorry to tell you, there's no dark side to the moon. It's just the same as the Earth. And I'll leave you with that thought and take your questions. Right, questions? Yes.
There's a lot of talk of electrical aircraft as our cars. Sorry, there's a lot of talk of electrical aircraft as of electrical cars, but you have to produce the electricity somehow.
Yep.
What is your proposed method for your popular aircraft?
I haven't got one. I can tell you what people suggest, and there is posited a huge increase in renewables like wind farms. There is, in terms of reducing demand, and you've seen a lot of this in the press, to get away from gas, to go back to use either air source heat pumps or ground source heat pumps. And anybody who's Googled me lately may have seen I was once connected with Ice Energy, which produced ground source heat pumps. And my former colleagues must be rubbing their hands now with the prospect of having to replace all the gas boilers in 2025 with heat pumps. But it's principally about renewables and nuclear.
But you've got to take it up in the airplane.
Oh, sorry, you were talking about, right, a factoid I missed out. Imagine an A320, easy to imagine around here. To get it off the ground, it would need batteries of 30 times the power density we have now, that are currently certified anyway. And it would fly half the payload for a fifth of the range. So the chemistry of batteries is the limitation. And that's why I and others cannot foresee a totally electric aircraft until the end of this century.
Why can't you make the wings
It's possible, and there is some research going on in making the surface of the aircraft, in fact the entire non-fuel part, when we're talking hybrid, as potentially a battery. Can I move on?
Yes, please. If nuclear fusion went somewhere at Cullen, and there's always noises that it might, would that change the situation about being able to hoover carbon out of the atmosphere?
Yeah, it certainly would. Dangerous stuff. I mean, we don't know how to control the plasma in fusion, and that's one of these great barriers of science, which we'll get over eventually, but it's not immediate. But there is some interest going on about returning to small fission reactors and the possibility of using small reactors as neighbourhood power supplies. And if that becomes something that's commercially viable, then people will invest on making those reactors as small and light as possible. And there might be an aviation application. But, you know, Henson and Stringfellow, George Cayley said, well, you need lift, you've got weight, you can't do much about that. Drag, you've got to design, and thrust, we're not quite sure about. Henson and Stringfellow took a coach, which was normally pulled by 4 horses, and that was the fuselage, and had a steam engine for the thrust. It didn't fly because they hadn't worked out the necessary relationship between those vectors, but watch this space. Okay, you got the mic?
Yeah, I got the mic.
I'll come to you next. Go on.
So, what do you see the future of supersonic and hypersonic flight? Is it compatible with reducing carbon emissions, greenhouse gases?
No, it's not compatible. The good bit of NASA research going on, because a couple of things that attach to supersonic flight. One is the boom, and NASA are doing some research with an F-18 and trying to find out where the level of public acceptability is. No one is yet positing that you would have another large, in passenger terms, hypersonic airplane, but Boom, the company in the US, show a business jet, which will carry 8 people or whatever, with a fuselage twice the length of this room, very Dart-like. I think there's a long way to go. On hypersonics, then this is what I said the Korean paper is about, masquerading as the civil application of hypersonics when actually it's a military application. I think there will be a long way to go before we crack the certification problems. So I don't see a passenger demand for that anymore, but I could be wrong. Right, yes, I said I'd come to you next, sorry. I'll look over this side of the room next, I promise you.
Thank you. Yes, back to the beginning of your lecture, you were talking about climate change. I've read, now I hope you can clear this up for me, that in perhaps 10 years, we might be facing another, what they call a grand solar minimum, or a Maunder minimum, that happened in the 17th century when the Thames froze over. So rather than the world getting warmer, in 10 years, we could be heading the other direction. Now, I can't answer this, and that's why I'm asking you. And then also, there's another question I think you will definitely be able to answer. Do you know anything about what they call air batteries?
Sorry, I didn't get the last phrase.
Air batteries.
Yeah, okay. No, I mean, climate scientists tell me if you look at the rebounds with climate temperature, which obviously goes in a sinusoidal way, then the extremes are getting larger, particularly the heat extreme. Beyond that, I'm not competent to answer. Someone down there?
Thank you. Do you have any forecast figures on the demand for the skills that would be needed to keep us competitive and keep us creating these technologies? Do we have the capacity for it at the universities that we're not filling, or do we need to create more capacity to produce these skills we need?
Mostly the former. And you know, universities are generally pretty good at responding, providing they've got the labs available or whatever. The problem, though, is, first of all, for electronic engineering, aerospace engineering, and mechanical engineering, you need physics. And 30,000 young men take physics A-level every year, only 7,000 women. So, in a sense, we're denying ourselves an undergraduate cohort which is skewed in one gender direction. Chemical engineering, you don't need physics. And if you look at Imperial, the female cohort in an average undergraduate year in reading engineering other than chem is 15%, and in chem it's 25%. So that's the problem, and we're working very hard on trying to get government and others to understand that this all goes back to teaching 7-year-olds mathematics. Because what we find is majority of primary school teachers have humanities degrees. They're fearful of mathematics and they inculcate that fear into their students. When they get to secondary school, where the pace really picks up, they tend not to be up with the hunt. And I made myself very unpopular at Universities UK, standing here on the stage with all the vice-chancellors there, telling them they're crap at teaching engineering. And they are. Because compared with a German or an Italian engineer, I work for an Italian company, quality of program and project management in a British undergraduate is awful. So we accredit them and we push them hard. But I think there is no, the problem is attracting more people into those sorts of degrees and definitely attracting more women. It's ridiculous. You can't deny yourself that. Yeah, right at the back. Hi. And then I'll come forward one table.
Thank you for your presentation. So my question to you is about carbon offsetting. You mentioned, well, the trees are not very effective and we need to plant just the double number of trees to offset maybe. And carbon capture and storage is what I figured is not as efficient. Do we know of any other technology that we can develop to cut down on carbon emission or also the non-CO2 emissions?
Not yet. We know a lot about carbon trading because in the EU's emission trading scheme, it's based on carbon trading, but Jonathan here will know much more about carbon trading than I do, and I bet he wishes he'd never heard of it. Sorry, there was one on the table ahead. Yeah, I'll come to you first, and I'll come to this table.
Hello. My question was, since the world in the next 20 years, let's say, is going to change so fast, and for undergraduates who just started their study, what would you recommend the universities as well as the students themselves do so that they can actually adapt to the skills that are going to be needed?
Sorry, I didn't get the end of that.
I mean, how would you recommend a undergraduate student prepare himself for the future that's going to be changing so fast?
Yeah. It's a funny old thing, aerospace, and I found this when I was interviewing people for the Megatrends research, that whoever they were, and I was interviewing people who were in finance, insurance, lawyers, as well as aerospace professionals, but every one of them had the one thing in common, and that is they'd had a spark of interest in aerospace and aviation very early on in their childhood. And that could have been, they lived in Southend and watched the air display every year, they were in the Air Training Corps, or there was an uncle who was in the Air Force, or whatever. But it was striking. And I think aviation and aerospace is different because, well, Formula One motor racing has replaced aerospace in the minds of young engineers or prospective engineers. And I know this to my cost, because they all tell me they want to go into Formula One. And I say, do you know how many engineers are employed in Formula One compared with aerospace? But that's it. You've got to get people really interested in aerospace. And then it takes over. The motivation and the absolute fascination takes over. But you have to do that proactively. I have a particular view, and I was doing a program for someone where I believe that STEM teachers in primary education are so precious, that they need to be treated in a different way. They need to be given the opportunity within their normal school working to spend say an afternoon with the local university in the research lab. They need to be in an engineering business for half an afternoon, preferably aerospace. But you know, you've got to feed that. You've got to motivate people to say, wow, you know, I was there and I saw this. And then it gets across and you develop that excitement. And the kids that we do cool aeronautics with love it. But unfortunately, you know, we do 200 at a time and there isn't anybody else who's going to be with them next week. But that's what it takes. We're also launching this month a soft launch of a platform for continuing professional development. And we've got to do that because we register our engineers and we're inspected. We're a regulator. We're regulated by the Engineering Council. And we're just wondering how we can use this much better in order to provide material for primary school teachers in particular. But it is this business of lighting that fire. Right, I'll go there, and then I'll go to the back. This one here, put your hand up. Have we got a mic? No, sorry, I thought William had a mic.
Good day, Mark Vellacott. In a previous life, I was biofuels director at the University of Queensland, and if you can't do biofuels in Queensland...
Were you in the Australian division?
I still am in the Queensland division of the Royal Aeronautical Society. I'm also a fellow. But one of the things that I found interesting about my experiences with biofuels is that people don't take into account the energy that actually is required to create the biofuels in the first place. And it's the energy exchange ratio. If you look at the energy exchange ratios with things like kerosene, it's about 20:1. So you put 1 barrel in to get about 20 barrels out, with all the refining costs of bringing it up. But with biofuels, you're lucky if you get about 2 barrels out for every barrel you put in. So biofuels are actually inherently quite dirty from an energy expense viewpoint, but nobody ever seems to take that into account when you factor in these net gains that you're seeing in the net fuel. So this is a real issue because at the end of the day, you're just pushing the problem further down the food chain and completely ignoring it. And yeah. I think the industry is kind of kidding itself that biofuels are the answer.
No, you're right. And you do have you have a couple of airlines who are actually total biofuel operators. I recall short-haul airlines, small ones in Australia. Yeah. So I know you're much more advanced. No, I agree with you. I mean, but we're only seeing synthetic fuels as a stopgap, and the degree to which you will find people interested in investing, and even in biofuels, if you look at the total requirement, the investment will be significant. I just don't think it's necessarily plausible. And it all depends on the research that's going on now into the next generation of battery chemistry. And we're doing some work on sodium ions, for example. And you know, if that progresses, it won't be market ready for 20 years, but that will be transformational. And so all these things will proceed in parallel. But it's not, you know, it's not easy to advise someone where to invest at all.
Yeah, I was also managing director of a company last year developing a solar-powered high-altitude aircraft. And I can tell you the battery technology is a long way off being able to cart human beings around the planet. Yeah. So there are some real challenges there. And personally, I believe that we should be sort of sucking it up and saying, it's a strategic industry for the world. We can only use carbons until we get hydrogen online. So we need to sort of ring fence aviation from that. Otherwise, the world's going to come to a grinding halt because we won't be able to transfer all the things we do currently in the air.
Yeah. There was one at the back. There we are.
On one of your slides, you had a saving of megatons of carbon based on changes in air traffic movements. Presumably that's partly stopping using the engines to taxi around the airplane and stopping, circling over stains or whatever. When do you think these will happen, and why are we still using engines to taxi around airports?
Yeah, well, there are two elements in the air, obviously, and the other, you're right, ground movement. At Singapore, my team tell me there was quite a lot of interest in electric tugs, and it will, I think, the pressure to get to net zero will see an increase in the use of electric tugs. I forget, there's one airport which is already trialling the use of autonomous electric tugs, which is quite interesting. But yeah, it will come, and it will be accelerated. One at the end there and one there. Do we need to knock it on the head? Yeah. Okay. Can we take one more? Okay.
I would tend to, just sort of on the comment from the gentleman from Queensland, I think that, for me, resonates quite true. But just from a layman's perspective, is there not, as we develop battery technology and other technologies to make flight more sustainable, is there not a need to also fundamentally change public perception as well, to ensure that, from a layman's perspective, they feel that flight not powered by fossil fuel is just as safe as traditional flight? Because I'm not from an aeronautical background, I'm just a meager MBA student. So as a potential customer, I would have perhaps reservations on getting on a flight that I didn't know the technology had been tested or had the flight time that fossil fuels have had. So is there not that need to change that public perception now, if what we're going to do is try and fill flights in the future?
Yeah, you're right. An airline based not very far from here, the CEO speaking at the Society said, there's no way out of this. You've got four groups who are insisting that you do your utmost to reduce carbon. One is the customers, obviously. One is the staff. One is the investors. And one is the sort of the people who peddle your broader reputation. And so there's no escaping this, you're right. And that's why public acceptability of advanced systems is the FAA's #1 issue. Well, after 737 MAX, but it's a big issue. Go on, I'll leave it.
Well, thank you very much, Sir Brian. I think we're going to say a few closing words, but that was a very exciting tour de force around the future of aviation, and yeah, lots to think about. But just a few comments on, I was very interested in the carbon emissions of short-haul aircraft, which is 133, and long-haul was 102. I can now I'll give you an early preview of IAG's performance in 2019. We've just finished a calculation, and it's 90. So I'm very pleased that we are well ahead of those numbers. So that will actually formally come out at the end of February. And to your question on biofuels, so I'll be doing a lecture on April the 16th, and I'll give you a lot more detail because BA have been heavily involved in biofuels. And just to say, there are sustainable pathways, and when we assess the sustainability of our biofuel, we have to do it over the whole life cycle. And so much more rigorously than we do with fossil fuels. And literally, you will not get any incentives unless you're at least 70% less carbon than fossil fuels. But I'll, just as a sort of I'll talk much more about that in the lecture in April. SA roadmap, well, what can I say? That was a lot of my life last year. It's the 4th carbon roadmap we produced, the 2nd fuels roadmap. And I have to say, we got more attention from this one than all the previous 4 put together. And you can look at, there were TV interviews, every TV channel interviewed, 40 newspaper articles. But the one that stuck out for me was, I don't know if you saw it, The Guardian. Now, The Guardian is not typically sympathetic to aviation. And their response to the SA roadmap was, it's just plausible. That is a massive win. That is the nicest thing the Guardian ever said about aviation, so we absolutely take that as a positive. What can I say? The UK fires report, yeah, that really that shocked us a bit. I mean, stop all flying, close all airports. The thing is that will not stop flying. People won't stop flying, they'll just get a train and a bus to Europe and they'll take a flight from there. Already today, there's 20 million passengers a year fly from the UK to a hub in Europe because of air passenger duty. Closing UK airports will do nothing for carbon emissions. And again, there were 2 letters in the FT in response. One was from Sustainable Aviation, unsurprisingly, countering the arguments. But I think the more unexpected one was from Bob Ward, the LSE, Grantham Institute, again, not normally sympathetic to aviation, and they said this report is far too pessimistic. There is a future for flying. So again, we took that as a real positive. So I like to think that DFT will actually take much more notice of the Committee on Climate Change report than the UK fires report. COP26, yeah, no, like you, we see this as a massive opportunity to showcase UK aviation. So we're working with IATA and Sustainable Aviation and with the Society to really make sure that we take that opportunity. And I'm an unashamed techno-optimist, yeah, mechanical engineer, and like you, I truly believe with ambition and political will, we can crack climate change. So thank you, Sir Brian, for your excellent presentation. I think you met both of Anna's requirements in terms of providing future direction and inspiration. So please, everyone join me in thanking Sir Brian.
From across the globe, from the centre of aerospace. And now to you.
Thank you for downloading from the Royal Aeronautical Society. If you enjoyed this content, please consider showing your support for the Society. Share a link to this presentation by email or on your favourite social networks. If you have an interest in aerospace, consider the professional and personal benefits of membership. Visit www.aerosociety.com.